this video, I'm going to dive deep into the FastMCP library and actually show you how it works under the hood. I haven't seen it in any other videos. Traditionally, all old software has been built with APIs. There's a client which requests data, for example users, and a server which returns Bob. But from 2024, the amount of AI agents and customer support chatbots has been growing exponentially. And that led to the concept of toolcalling. Toolcalling lets the AI move beyond static training data to become more capable and use external tools, APIs, or databases to get real-time info or take actions. Now let's take a look at an example. Okay, so I want to do a little role play with you. Imagine you are a developer in 2024. So you want to build an autonomous agent with function calling. And it's going to help you search for information on your Notion. You have a big Notion with many pages. So here I built a sample Notion. There's a couple pages: weekly habit tracker, personal goals, health and appointments, grocery list, monthly budget. And we want to be able to find information about this. Now the process for building something like that would work as follows. You would use something like LangChain agents, and then we would get the Notion API, of course, with the Notion client. And we would have a couple functions. So we're going to have a Notion search function, which is just going to call the API, the query, and we will get the page from it, extract the title, the page ID, and the URL. And we will return this as a result. And using the page ID, we can get the content as well. So for this, we can just call inbuilt Notion client functionality. Next, we extract the title and get page content, just blocks, and we just extract all the content and return this as well. The second step, we're going to wrap these functions as tools. Notion search tool with the description that the AI can use, and a function, and the same for the get content tool. And the third step, we will initialize an agent and pass these tools to the agent. And finally, well, we can test it. We're going to get pages about monthly budget, and we're going to get the upcoming appointments we have. As you can see here, it gets the page and the content as well. And here, it has problems fetching the page. It has an issue with the page ID. It should be a valid ID, but it has the wrong kind of value. It's invalid. So this is one of the challenges that there was in building these kind of agents. It was very hard to get the parameters right. The LLM would sometimes get the wrong parameter name, wrong parameter type. In order to address this challenge, there were a couple approaches. One was to clean up the parameter inside of the function. Another approach is to update the prompt. So we actually give an example. And so here we can see it got the right result now. So the upcoming appointments are dentist checkup, annual physical, and as we can see in our Notion, well, it's correct. This was one approach. The other approach would be to improve the description of this function, which the LLM can then use. You'll probably think, what if we give more context to the language model about the types and the parameter names? So a popular approach would be to send an OpenAPI specification like this. It mentions an endpoint, it mentions a type, it mentions parameters, query, and does it for many calls. So this was another approach. You would write a massive prompt, specify each of your endpoints of the tools and the parameter types, etc., etc. And this would help improve the accuracy as well. But getting this prompt right, it was a huge challenge. The challenges that organizations and developers faced with this approach are two. Firstly, we discussed the accuracy. The LLM would get the parameter names wrong, the parameter values wrong, and the types wrong. And the second thing is reusability. We just wrote two functions and tools, which is a bunch of code. In this time, there were hundreds of people who wanted to use the Notion APIs for their AI, and they had to rebuild all of that themselves. Introducing Model Context Protocol. As you can see here, there is an MCP server, which is basically something that wraps all of these API calls to Notion or Slack, but you can reuse it. You can plug it in to your MCP client, like our agent or Cloud or ChatGPT, and this way every developer can reuse it. And it also improves the accuracy. I can hear you thinking, okay, I can get that, but how does it improve the accuracy? In this video, I'm going to dive deep into the FastMCP library and actually show you how it works under the hood. So just for that, I haven't seen it in any other videos. Smash this like button and click on subscribe. And that brings us to MCP. Now I just set up a simple starter project. It has one file, server.py. We'll get the FastMCP package and the Notion client, and we can literally reuse the Notion functions for search and get page content. And we now use a client to check for API key, and we define our MCP with the name. And all we have to do is literally add a decorated MCP tool, and that's it. Suddenly, it's become reusable. Now let me show you in action how this works. We can add an MCP to Cloud. So I open Cloud, and you can go to Settings, Developer, and then you can Developer, and then you can edit the config. So I already edited it. You basically have to add this MCP server name to your MCP servers, and then the command how to run it and the arguments. So if you can see, if I run this, it works. And now Cloud is pretty much going to run this under the hood. So if you open Cloud, it's in there. You need to restart it before it will appear there. Here I can say, look in my Notion for fixed expenses. You can see that it will use the Notion MCP to search for fixed expenses. Okay, so it found the page, and it also found the content. So it's become reusable, and besides that, the accuracy issues it had with parameter names and types, it's been solved as well to a large degree by the MCP server. So let me show you under the hood how the MCP server actually does this. This is the only video so far where anyone does that. Okay, I just went into the FastMCP library, and we can see client here, server, and tools. And in server, that's where it starts. So the moment you have a decorator, this thing happens. So this is the one that the function that's acting as a decorator, and it's going to register the tool and return a tool object. So pretty much there is a dictionary of tools it's keeping track of internally in a dictionary. So basically it's just storing all the tools in a dictionary inside, and it's going to do some interesting things here. So it's going to do a from function, and when we go in here, it's going to create a tool from a function. And the from function uses parsed function. Now here, some really interesting things are happening. Firstly, it's getting the name of the function and using the doc string to get some understanding which the LLM can then use. So it's actually going to get the doc string for the LLM. And then besides that, it's going to infer the types of the parameters and the schema that an LLM can then use as well. And it's also going to define an output schema. Now what's interesting here is it's not using an open API schema, but a JSON schema. And a JSON schema is actually much smarter than, well, what many people used to do with open API schemas, because it has a lot less irrelevant data. Okay, so I just ran this, and I'm logging everything into a file called MCP Server debug log. Now let's see what it's tracking. So the function name, Notion search, document, search for pages in Notion by title or content. Now let's take a look at the input schema. Additional properties, query title, query, type string, required query, type object. Output schema, properties, result, type string, required result, type object. So here you can see it already made the schemas for us. And it's even getting the types. When the LLM calls one of the tools, it will run the function. And this is going to validate the parameters, whether it is according to the right types of this function, using type adapter validate Python. And what this is actually able to do is it's able to coerce the types so it should fit a certain schema. So let's say the parameter is actually a string and we want a boolean, it's going to convert it to a boolean. So this way it's already solving a bunch of type issues. Okay, so we have the MCP server, but how can we debug this? Well, you can run a command like npx model context protocol inspector uv run server pi. Now what this is going to do, it will open up a UI interface like this, and in here you can connect to the MCP server. Now once it's connected, you have this nice UI. So you can list your tools, and from here you can even call tools. So you can say monthly expenses, and then you can run the tool. You see here the output schema, metadata, and we can see in here the tool call, the response, and so we can use this for debugging purposes. Now, what if you want to use this into production? Now, for production, you can use various observability frameworks. From my own experience, I've used Langsmith, and then basically you will have something like this show up in your observability dashboards. Now, for more information about Langsmith, you can subscribe to this channel, and I'll bring out another video for that. For MCP, there are 3 protocols: standard I/O, server-sent events, and streamable HTTP. So far, we've been running it locally with standard input-output. This is just running locally with something like command line interface. But what if you want to make a remote server? So initially, when Anthropic made the MCP protocol, they went with server-sent events. If you want to do server-sent events, we can just add in a transport here for SSE, and then if we run this, and we look into the inspector, we can now type here SSE, and we can connect. So this way, you can make your MCP server accessible to the rest of the world. Now, the problem that organizations and developers faced with this approach is that server-sent events is stateful. So what this means is that you need to have an ongoing connection, and this means that you cannot easily scale up this MCP server of yours. And that is why they created a new protocol, streamable HTTP. And for that, all you need to do is change the transport here to HTTP. Now we have ourselves a MCP server with streamable HTTP. So basically, the server-sent events protocol is pretty much outdated now, and for remote servers, it's recommended to use streamable HTTP. That brings us to the MCP client. The MCP client will have a config, as we have seen before, which will define all the MCP servers and how to run them, so in this case Notion. And it will be connected to the Notion MCP server. Now we're going to have a very simple flow for this. A user can ask a question, like look in Notion, what are my fixed expenses, and the LLM will give back a response. However, the LLM has some context. It has information about the tools and the types and parameter names. Now where does it get these JSON schema? Now where does it get this context from? Well, we saw that the MCP server creates schemas for all the functions when converting the functions to tools. And it will pass these schemas to the MCP client as JSON schemas. The MCP client will then give this information to the LLM. However, it will first convert it into a cloud format or OpenAI format, which is slightly different than the JSON schema format. And so when the user asks, look in Notion, what are my fixed expenses? The LLM will look at its tool calls, and it will call something like Notion search or Notion get page content, and it will call the tool, which it will do with the MCP client. Now the MCP client is going to tell the MCP server, hey, someone told me to call this tool, can you run this for me? The MCP server is going to run the tool, and inside it will validate input parameters and coerce any parameter types as well. So int20 would become string20 if the type in the JSON schema was a string. And then it's going to return the response to the MCP client, which will then return a response to the LLM. So the MCP client is basically an intermediate layer, some kind of interface between the LLM and the MCP servers. Now we got that clear, let's dive into the code. We'll start by importing the client from FastMCP, and this is going to be the LLM. And we will get the MCP config. Alright, so I can type a message here. Get my fixed expenses. Alright, I'll search for you, fixed expense in Notion. Well, here you can see it's calling the tool, and this is the debug information that I was just logging from the MCP server. I didn't find any pages, but let me try some alternative service expenses. So now it actually finds the page ID here, and it's going to get the details. It's going to do Notion get page content call. And finally, it gets the result, and here you can see it right there. Another common question I get asked is what about authentication, authorization, if you want to protect your MCP server? The MCP protocol supports OAuth, and you can use something like bearer tokens. So let me show you how that would work. I'm now going to demonstrate to you how authentication would work with an MCP server by showing you a live example. I'm going to use an MCP server with Cloud Code. If you go into Cloud Code, we can do MCP. It's going to list all the MCP servers, and basically we will need to add a server first. So I'm going to add the Notion MCP server. It should be added like this. Notion. Right. So now I added the Notion MCP server. If I run this again, we will see Notion is in there, and it says needs authentication. So that's what I was talking about. And that's going to be the same thing in your config file. Someone could, for example, pass a variable like environment with some API key. So if we look here, you could also add an env parameter to your config and just pass a key there. And this is exactly how this could work, for example. So it tells you that it needs authentication, and then here I need to open the browser and authenticate here, and then finally I can use this MCP. So now tell me my fixed expenses. We can see that Cloud Code can even call the Notion MCP as well. And there you see, it's the same response. Right, so what kind of technologies can we use to build MCP servers? We have by default the SDKs from Anthropic for Python and TypeScript, and they also support Java, Kotlin, C#, and Rust. And for MCP clients, we have something as well. Now besides the support from Anthropic, we can get the Python client from MCP Use. So MCP Use, it's more versatile, and you can use your own LLM with this, from what I understand. And another thing you can use is we can use LangChain with MCP for client. And besides that, we can also use Mastra, which is really good for TypeScript. And for no-code options, you can look into something like initn, make, things like this. They have MCP clients and servers in initn, for example. This was all for this video. If you have any questions, put it in the comments, and I'll see you all in the next video.